Good morning, everyone. I am Lisha M. Today, we'll be looking into IR spectroscopy, modes of molecular vibrations. Now, let us look into what is IR spectroscopy. IR spectroscopy measures the absorption of infrared radiation by molecules, revealing functional groups through characteristic vibrational frequencies. The fundamental principle: molecules absorb IR radiation when the frequency matches their vibrational frequency and when absorption causes a change in the molecule's dipole moment. The IR radiation range: near IR 12,500 to 4,000 per centimeter, mid IR 4,000 to 400 per centimeter, far IR 400 to 10 per centimeter. The key condition: vibrations must produce a change in the dipole moment for IR absorption to occur. Degree of freedom and number of vibrations. A molecule with n atom has 3n total motions. Linear molecules have 3n minus 5 vibrations. Nonlinear have 3n minus 6. Example: CO2, which is linear, has 4 modes. HO2, which is bent, has 3. Types of molecular vibrations. Vibrations are either stretching, bond length changes, or bending, bond angle changes. Bending includes scissoring, rocking, wagging, and twisting. Stretching vibrations. Symmetric stretching. Both terminal atoms move away from or towards the central atom simultaneously. Result: no change in dipole moment for symmetric molecules, which means maybe IR inactive. Asymmetric stretching. One bond lengthens while the other shortens. Atoms move out of the phase. Result: change in dipole moment, always IR active. Higher frequency. Asymmetric stretch absorbs at higher wave number than symmetric. Hooke's law. Frequency depends on force, constant, and reduced mass. IR activity. Only vibrations that change the dipole moment are IR active. It's a selection rule. Bending or deformation vibrations. Scissoring. In plane, the two atoms move toward and away from each other within the same plane, like scissors opening and closing. Frequency lies between 1400 to 1500 per centimeter. Rocking. In plane, both atoms swing in the same direction within the plane of the molecule, like a pendulum rocking side to side. The frequency lies between 720 to 900 per centimeter. Wagging. Out of plane, both atoms move simultaneously up and down out of the plane while the central atom stays in the plane. Frequency lies between 1250 to 1350 per centimeter. Twisting. Out of the plane, one atom moves up while the other moves down out of the plane, a twisting or a torsional motion. Frequency lies between 1050 to 1350 per centimeter. A case study on vibrational modes of CO2. CO2 has 4 modes. Symmetric stretch. Both CO bonds stretch simultaneously in phase. No change in dipole moment, not observed in IR but Raman active. Asymmetric stretch. One CO stretches while other compresses. Strong dipole moment change, strong IR absorption at 2349 per centimeter. Bending. O atoms move up or down perpendicular to molecular axis within the plane. Doubly degenerate with V3B. Bending. Out of plane, O atoms move in or out of the plane perpendicular to molecular axis. Same frequency as in plane bend, degenerate. Characteristic group frequencies. Different functional groups absorb at specific wave number. Example: CO at 1700 per centimeter, OH at 3200 to 3600 per centimeter. The fingerprint region 1500 to 400 per centimeter is unique for each molecule. Factors affecting vibrational frequencies. Frequency shift occurs due to bond strength, atomic mass, electronic effects, physical state and environment, coupling and Fermi resonance, molecular geometry. The information is as in the slide. Applications and key takeaways. IR spectroscopy is used for structure determination, quality control, forensic analysis, and environmental monitoring. Key takeaways. Molecules have 3n 5 linear or 3n 6 nonlinear vibrational modes. Vibrations are stretching, bond length change, or bending, bond angle change. Only IR active vibrations, those changing dipole moment, appear in IR spectrum. Frequency depends on bond length and atomic mass. Hooke's law. Fingerprint region lies between 1500 to 400 per centimeter is unique to each molecule. Thank you.